All right, so I'm going to go ahead and do 1, 2, 3, and 4 first. So 1, 2, 3, and 4 say, for each of the following integrals, state whether u substitution or integration by parts should be used. So if you notice, question 1 and question 2 are pretty similar. Question 1 says the indefinite integral of x times cosine of x squared dx. Question number 2 says the indefinite integral of x squared times cosine of x dx. Notice, all that really happened was we switched the x and the x squareds. 3 and 4, again, are very similar, so we've got the indefinite integral of x squared times e to the x dx, and we've got the indefinite integral of x times e to the x squared dx. So again, all we're looking for, it doesn't ask us to solve, it just asks us which method is appropriate, which one is the correct one to use. So again, if you're using u substitution, you are looking for some expression that you can write as a u, whose derivative is also already in the problem. And so if you look at number 1, that's should be pretty easy to identify as a u sub question. Okay, and the reason I would identify this as a u substitution question is if I switch this as u for x squared, then its derivative is 2x dx. Now, if you notice, if I switch that for a u, it's not so hard for me to imagine just saying, oh, I've got the x and I've got the dx already in the problem. And so this, again, is a good u substitution question because I can really deal with that 2 by just moving it to the other side and making it a 1/2. That's not an easy thing to fix. That's not a hard thing to fix. So, like I said, this is a very simple u substitution question. It would just be cosine of u, and we would have a 1/2 on the outside. However, on number 2, it's a little bit more difficult because there is no u substitution, because if you were to try to substitute a u for that x, its derivative would just be 1 dx. And unfortunately, that doesn't handle that x squared out front. That's not part of the derivative. And so in this case, this is an integration by parts question. I'm going to write IBP for integration by parts. And so I want you to think about this and kind of say, well, if this is going to be an integration by parts question, what are going to be the 2 things that I need? In this case, the u and the v prime, or the derivative of v. So what are the 2 things that I have? Well, in this case, the u, the thing that is going to simplify as we go, is going to be that x squared. Because when I write an expression for u, I want it to simplify, or I want it to get nicer and easier as we go along. I don't want it to become... I don't usually want it to be one of those functions that repeats. Generally, those don't make things a little bit easier. We would much rather have this v prime be something that repeats, like, for instance, in this case, cosine of x. Because that way, this x squared is going to kind of disappear the more we do the integration by parts, and this cosine of x is just going to kind of come back around and repeat. However, let's go ahead and look at number 3 and 4. Very similar kinds of questions. If you look at number 3, again, I can't really use a u substitution on that x because it wouldn't handle the x squared. So this is, again, another problem that integration by parts would be more appropriate on. Similarly, we would use u is x squared, and our v prime would be e to the x. Now, that's an important thing to think about, again, because if you were to integrate this v prime, it would just be e to the x again, and that would turn into 2x, which, again, would be a little bit simpler than that x squared. However, on number 4, just like number 1, it is a u substitution question. The reason it's a u substitution question is if I were to look up here in this exponent and do u equals x squared, its derivative would be 2x dx. So this actually would become an e to the u, which, again, you guys have seen that a lot. It's not a particularly challenging integration question at that point. Again, all I would have to worry about is that 2 out front, which is not a very difficult thing to handle. I'm going to come back and do the rest of these problems in just a minute.